The arc length of any arc on a circle of radius r that is subtended by an central angle of theta radians is equal to S equals r theta. That was a really complicated statement. Basically, all you need to know is that if you have a circle and you know its radius r, and you want to know, if I have this angle here, how long is the arc that goes from here to here? How long is that length of the edge of the circle? You can use the formula S equals r theta. That's what the arc length theorem is telling us. But the most important part here is that we have to make sure theta is measured in radians. That's because of how we defined a radian to be the length of one radius around the edge of a circle. So those two things go together. Let's give this a try. Find the length of the arc of a circle of radius 2 meters subtended by a central angle of theta equals 1/4 radians. So the arc length is equal to the radius times the angle, central angle given in radians. Well, we know that the radius is 2 meters and the angle in radians was given to us as 1/4. So we get 0.5 meters is the length of the edge of the arc that looks like this on this particular circle. Let's look at another one. A wagon wheel with a radius of 17 inches. How long is the arc subtended by the central angle of 2 pi over 3? So notice 2 pi over 3 does not have a degree symbol on it. That means that our theta is in fact measured in radians already. So S equals r theta is our formula for arc length. We can take 17, which is our radius, times 2 pi over 3, and that will give us 34 pi over 3, which is, if we put it into our calculator, 35.605 inches is how long that arc that is subtended by 2 pi over 3 measures. Finally, on a circular fan of radius 15, how long is the arc subtended by the angle 218 degrees? We can see here that the angle is not measured in radians, so we need to convert it to radians. So remember, we start with 218 degrees over 1. We're going to multiply this by pi over 180. We want the 180 degrees to cancel the 218, and remember 180 degrees is pi radians. So in radians, this is 218 pi over 180. If we put this in our calculator, that's 109 pi over 90 radians. Now that our angle is in radians, what is the arc length subtended by this angle? Well, S equals r theta. So we'll take our radius of 15 feet times 109 pi over 90, and that will give us an arc length of 57.072 feet when we put that into our calculator.